Hello, today is going to be our start or introduction to looking at two-column proofs. So what a two-column proof is this table we see right here. The left-hand side are statements, the right-hand side are reasons. So I want to talk a little bit about what each of those things mean and what a proof does. So a proof is just a very organized way of saying, I can say this for sure mathematically because of information I've been given or properties and postulates and things like definitions that I've learned before. So we've already learned quite a few properties and postulates and definitions. We're going to continue to learn more. So especially starting out with proofs, I'll give you a bank of things that we can choose from to complete these proofs. So for today, instead of writing a whole proof from scratch by yourself, you'll be filling in this case, reasons, or sometimes it'll be a combination of statements and reasons to complete the proof. How a proof works, you're always given some piece of information. It could be just an equation like this. It could be multiple equations. It could be a picture. It could be both. So they've given us AC equals AB plus AB, and they've given us this diagram with A, B, and C on that line segment. What we want to end up concluding or proving is that length of AB equals length of BC. So we are going to take things step by step to get from our given to our proof. Our given is always our very first statement, or if there's more than one of them, they're usually towards the beginning. Our proof is always what we finish off with. Reasons, again, are going to be things like properties, postulates, definitions, information and definitions that we have learned that we can use to argue why we say these things are true, not just because someone should just believe us. So we're backing up our claims here. So we always start our proof with what we've been given. So they say length of AC equals length of AB plus length of AB. How do we know that? It's not clear in the picture. We can say that because it was given. This right here was given. So when something is just given to us, we just write the word given as our reason. Basically, it's just saying it's true because you told me it's true. From here, we want to continue on. So now they're saying AB plus BC equals AC. This looks an awful lot like something we've talked about before. Let's look at the picture. They are saying that the length from A to B plus the length from B to C is equal to the length from A to C, which is the whole line segment. That is exactly your segment addition postulate. Segment addition postulate says that when you have a point that's in between 2 points, the distance from first to the second plus the distance from second to third is the same as the distance from the beginning to the end. I'm abbreviating addition there a little bit there because I can. So we've used segment addition postulate. From here, now they're saying, okay, we know that AC is equal to AB plus AB. We know that AB plus BC equals AC. They are now saying AB plus AB equals AB plus BC. Notice that we have AC here, we have AC here. So the way we've seen this before is, I'm going to write it down here. I'm going to kind of write things in a different order. AB plus AB equals AC. AC equals AB plus BC. We know that if we have the same thing here and the same thing here, we can say that the first thing and the second thing are equal. And that's exactly what they're saying. AB plus AB equals AB plus BC. That is an example of our transitive property. I'm just going to write transitive. Last but not least, concluding that AB equals BC. So how did we get from this equation here to this equation here? What happened? Well, what we did was we subtracted AB from both sides, which canceled on both sides. We were just left with AB plus BC. So since we subtracted the same thing, AB from both sides, that is our subtraction property. Our proof is now complete. We now have reasons behind every statement we've made, so we are finished. Let's try another one. So once again, we're given the proof. This time, though, sometimes we have reasons that are missing, sometimes we have statements that are missing. So here are the things that are kind of our bank, the things we're choosing from. Substitution property. Angle 1 is congruent to angle 3. Measure of angle 2 plus measure of angle 3 equals 180. Definition of supplementary angles. Given. And subtraction property. So they say angle 1 is supplementary to angle 3. How do we know that? We know that because it is given. They just straight up tell us that. So that's how we can say that. They told us that. We don't have to do any concluding or really thinking too much on our own for that. The next thing is they say that measure of angle 1 plus measure of angle 2 is equal to 180 degrees. How can we say that? Well, if we go back to statement 1, they say that those two angles are supplementary. We know that the word supplementary means that you have two angles that add up to 180. So then what we're going to say here, I'm going to abbreviate definition of supplementary angles as our reason. We've used that. Okay. Next thing they say, angle 2 is supplementary to angle 3. How do we know that? Hey, look, they told us that. Since they told us that, that is also given. All right. And then let's kind of see what we did here. So the first time they said 1 is supplementary to 3. 1 plus 3 is 180. 2 is supplementary to 3. What can we say about 2 and 3? We can say that measure of angle 2 plus measure of angle 3, since they are supplementary, equals 180. And that goes back to our definition of supplementary angles. Done. Okay. Now the next thing they're saying that measure of angle 1 plus measure of angle 3, measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. So how can we say that? How can we say that for sure? Well, since this is 180 and these things equal 180, I can take measure of angle 2 plus measure of angle 3 and put it in here. And that's exactly what happened here. Instead of writing 180, I wrote measure of angle 2 plus measure of angle 3 because they're equal to the same thing. Since we are using things that are equal, that is the substitution property. We replaced one with another. All right, next up, equation looks sort of similar, except for how do we get from step 5 to step 6? Step 5 said measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. Now this just says 1 equals 2. Well, if I subtract measure of angle 3 from both sides, it cancels on this side, cancels on this side, and I'm left with measure of angle 1 equals measure of angle 2. So since I subtracted the same thing from both sides, I used my subtraction property here. And then last but not least, since these are equal, what they want us to prove is that they are congruent. And since the measures are equal, that means the angles are congruent. So we can say angle 1 is congruent to angle 2, or this should be a 2 here, I'm sorry, angle 2. So by the definition of congruent angles, we can say that angle 1 is congruent to angle 2. We couldn't have just said that from the beginning. We had to go through all these steps to get there. So once again, you usually start with your givens towards the beginning. Your very last statement should be whatever you were trying to prove, but you need a reason for why you were going to prove that. That is it for today. I know proofs can be new and different and a little scary, but we'll get through them together, and we'll take them step by step and break them down like we've been doing. Have a wonderful day.